Okay, so we're going to take a look at what to do in situations like this when we have equations that need to be solved with brackets. So let's say you've got something like this. Okay, if you have an equation like this where you can see brackets, it's really easy. Generally, the first step is just to get rid of the brackets. Okay, so we expand. You'll remember that we learned how to do this in our algebraic technique. Okay, so we use distributive law to multiply what's outside the brackets by everything inside the brackets. 2 times 3x is 6 times x, and 2 times -1 is -2. And now we just have an equation that we have to solve the usual way. Like this, 6x equals 13. And we divide by 6 to get we can just leave it as 13 over 6. Or you can write it as 2 and 1/6. Or you could even write it as 2 point, I don't know what that is as a decimal. Okay. All right, so I'd have to use a calculator if I wanted to do it quickly. All right, so the upshot here is when you see brackets like this, the easiest way to get rid of them is just to expand them using distributive law. Okay, like that, and then solve it. Sometimes you get equations where you see something like this. Okay, so the first step is get rid of the brackets, right? You can't solve until you get rid of the brackets. Well, you can in some circumstances, but you can in all circumstances, but you can make it harder for yourself. But I'm not going to talk about that right now. So let's get rid of these brackets. So 2 multiplied by x is 2x. Whoops, I forgot to draw my line going down. And 2 multiplied by 3 is 6. And I'm just going to rewrite that here. So now you can see that there is an x on both sides of the brackets. We've got 2x here and we've got 4x here. All right, so the trick here is to combine like terms. So we're going to gather up one of these x's and stick it over the other side so that then we just have one x term, okay? So these are both positive terms. Now, I tend to, you can grab the 2x and put it over that side and make it, combine it with the 4x, or you can take the 4x and put it over that side and put it with the 2x. The way I tend to do it is I choose the one with the smallest value. So to me, that's 2x, okay? So I'm going to do the 2x. Sometimes if you choose the one with the biggest value, you can just give yourself negative numbers, which people don't like to work with. So let's just choose the 2x, right? So this is a positive 2x. So I am going to minus 2x from that side of the equation, okay? Put brackets around it if you need to remind yourself that these terms belong together. All right, so now these things here will cancel each other out. 2x minus 2x is 0. So we'll be left with 6 on the left-hand side. And then we've got 4 x's minus 2 x's, which gives us 2x. Okay. Now I've just got a normal linear equation to solve. You can put these around the other way if you like. So you can put the 2x minus 8 on the left-hand side and the 6 on the right-hand side if that makes more sense to you. But it really doesn't matter. You can do it either way. So we just solve here the usual way. So we're left with 2x on the left side and 14 on the right side. And if we divide by 2 on both sides, we end up with x equals 7. All right, so I'm going to read this out. Using x for the unknown number, write down an equation, then solve it to find the number. So the product of 2 and 3 more than a number is 7. So the product of 2 and 3 more than a number is 7. So we have to start with that part, 3 more than a number. All right, so let's use x as the unknown. So 3 more than a number means x plus 3. 3 more than a number. So here's our number, and that's 3 more. We add 3 to it. And we're working out the product of 2 and that. So we have to put this in brackets because these guys belong together. And to 2 lots of that is, we do this, okay? Invisible times sign here. And we're told that it equals 7. All right, so 2 times x is 2x. 2 times 3 is 6. And then we just solve in the usual way. Notice how I'm picking up the pace now. Not writing down all my working out. Not every single bit of it anyway. Okay. The product of 3 and 4 less than a number is -4. So we have to start with that part, 4 less than a number. So a number and 4 less than that is subtract 4. We're going to multiply that by 3. And we're told it equals -4. So we're going to expand the brackets. And we're going to solve it. So 3x equals adding 12. So we get 8. And dividing by 3. Oops, that's not right. Dividing by 3 so that x equals 8/3. Okay, now I'm going to do question 7. Let's have a look at question 7. All right. So question 7, I'll read it out. Since Tara started work, her original hourly wage has been tripled, then decreased by 6. It is now to be doubled so that she gets $18 an hour. Write an equation and solve it to find out Tara's original hourly wage. So her original hourly wage is the unknown number here, and we have to call that x. Okay. Since she started working, it has been tripled. So when you triple something or treble something, you times it by 3. Okay, so 3 times the original, and then decreased by 6. That means we're subtracting 6 from it. It's now to be doubled so that she gets an $18 an hour. So we put this in brackets if we want to double it, okay, and times it by 2. And it will now be $18 an hour, all right? Remember, this is similar to a test question. So we have to expand the brackets and solve it. So we're adding 12 to both sides. And dividing by 6. And we see that her original hourly wage was $5 an hour.